Today, as it says, equations both sides of the variable. So an example might be something like this: x equals 4x plus 18. What I generally like to do, and you don't have to do it this way, but I like to find the smaller of the two and do its opposite. Then we have a positive x on it. So in this case, there's 4x. Positive 4x, the opposite is going to be negative 4x. We do it to one side, we do it to the other. You only put it underneath the variables. We can call it term one. So we get 4x minus 4x goes away. 6x minus 4x equals 2x. Now we have a one-step equation. Divide by 2, x equals 9. Okay, so we want to find the smaller of the two, move it over. We might have some that include a fraction. You can do it a couple ways. You can just work it as a fraction, or we can get rid of the fractions from the start. Personally, I like to get rid of the fractions from the start because it'll make it a much easier problem. We find what's the common denominator between all three of these. There's only one, so that common denominator is 5. So now what we do is multiply every single term by that denominator. Here, what happens with 5 divided by 5? Cancels out. So we're left with 4x plus 15 equals 5x. Now we have no fractions, and it looks a whole lot more like that one, doesn't it? So, which is our smaller variable? 5x. Okay. What's our smaller variable? 4x. We're going to do the opposite. So that goes cancels out. 15 equals 5x minus 4x, which is just 1. Okay, so we made it a simpler problem by getting rid of fractions. We're going to do another fraction type one. We have 8 plus x all divided by 9 equals x. So we have this division. How can we get rid of division? We're going to multiply both sides by 9. In the process, we cancel our 9s. 8 plus x equals 9x. Much simpler to start now. How can we get rid of this positive x? It's the smaller of the two. So we're going to subtract x. 8 equals 9x minus x, which gives us 8x. Divided by 8. X equals 1. All right, one last one. This one, we're going to have several steps. And that is okay. We're taking several things we've done over this chapter and combine them. So we have a parentheses on one side. We have multiple variables on the other side. Make sure I have that. So I have parentheses. This is where I'm probably going to start, just so we can simplify bit by bit. Again, try not to do too much at once, because that's going to make mistakes. 7 times a is 7a. 7 times negative 2, negative 14. Now we want to look at each side. Are there things we can combine? This side we have constant terms. This side we have variables. So over here we have negative 16, excuse me, negative 14 and negative 6. Same sign, so we add 7a and negative 20. 2a plus a, what's that? 3a. Oh, we're already much simpler. Okay. What's our smaller variable? 3a. It's positive, so we're going to subtract. 4a minus 20 equals 8. So now we're basically at the two-step equation. Here's our variable, so we want to get rid of negative 20. Add 20. 4a equals 28. Get rid of multiplying 4 by dividing by 4. A equals 7. Okay. The key on any type of equation, don't try and do too many steps at once. Show your work so you're keeping everything straight. It's really simple to miss something. Even when I work these still, That's how much work I show every time. I want you showing your work. Right, Josh? Okay. Check. All right, so today on page 1H, 13 to 33 odd. The other thing I did not mention, let's do one more example. This is not all. We need to do one more example. So this one, let's see why I want to do this in a second. We've got parentheses, so I'm going to distribute on both sides. 3 minus 3r plus 5r equals 2r plus 2. So these are the same, so we can put them together. We have positive 5 and negative 3. 5 minus 3 is 2r. All right, they're the same, so let's get rid of one of the r's. So subtract 2r. That goes away, that goes away. We're left with 3 equals 2. Is this a true statement?
No.
That does not equal to each other, so this one is no solution. It's possible, let's say, I'm going to change this real quick. Let's say it was this, and it was true. If it's true, then it's identity for all solutions. So it wouldn't have mattered what x equals. So if it's true, it's this. But in this case, it was false. If it's false, it's no solution. Okay, you will have a couple like that today. So if your two numbers come out to be equal, or if you get like x equals x, then it's true or identity or all solutions. But if it's a false statement, it's no solution because it doesn't matter what you use for x, it will always be incorrect. So on page 118, 13 to 33 odd. The last couple will be like this.